Picking up with the example we left off on. What's all that stuff on the left? Integration. And who am I actually, if you're not a physics person who just memorizes formulas, not that that's a bad thing because then you have to know how to use them. Physics is not just understanding your tools, but being able to use them appropriately and use multiple ones in a certain situation or scenario. It's tricky, it's puzzling, it's interesting, and it's kind of brutal. But what did we have here that we were able to found, that we were able to start with, we were able to build all the rest of our information on? What was the one fact we were able to use? Acceleration for a free fall model, something that is being thrown up and coming down, or being thrown down and then coming back up, is always going to be negative gravity. And what is gravity? We have a constant for gravity. Gravity is gravity is gravity is gravity, unless you're on the moon or unless you're off the earth or unless you are in a different part of the earth, but it will be so minute, the differences, that it won't make a big difference for, well, basically kids like us. So, gravity, that's our truth, that's our foundation, that's our beginning fact. Gravity. All of this is built on gravity, because if you have gravity and if it is acceleration, then how can I get velocity if I have acceleration, since velocity's derivative is acceleration? Integrate. And when I integrate a constant, I get a constant times a variable plus c. But what did we see yesterday? Our c is going to be in a simple model like this. Initial velocity. Which, were we given an initial velocity for this problem? Yes, so we could have just plugged in plus 64, or we could have plugged in when t is 0, velocity is 64, and solved, and then plugged it in. But as soon as we have a velocity equation, what can we now create? Well, we're doing math, but in a sense we're creating. With an integral, we can create what type of function? Oh, so awkward. With an integral of velocity, we can create what type of function? Who is this? It's not time. Time is in position. Yeah, position. Time is kind of like that independent. He's the guy who's working through everything. He's technically present in acceleration, although it's the same at every time. He's working in velocity because velocities are changing. It's being thrown up 64, but what's going to happen as soon as the ball is released to velocities, guys? Increasing or decreasing? As soon as the ball leaves the person's hand, what's going to happen to that 64? Just using your practical life skills. No, the ball's position will be increasing. The ball is going up, but what's happening to the velocity as soon as it leaves the hand that's thrusting it up? Why is it going to be decreasing? What's gravity doing to that 64? Pulling it down, right? Trying to pull it down. Is the ball going to move up? Yes, of course, until gravity wins. And when gravity wins, it cancels out that upward thrust, and all of a sudden, or that upward velocity, and all of a sudden, we have negative velocity. Velocity is decreasing as soon as it leaves the hand that is throwing it up. Anyway, getting the position function is an integral. The integral of negative 32t is negative 32t squared over 2 plus, oh, he's a constant, b sub naught t, plus c. But who's c in something as simple as this? A polynomial function, c is going to be the initial. Now, I put x sub 0, lo siento. I was using that other notation on your guys' forever card. Didn't we say yesterday that position can be either s or x? So since I put an S up here, I should have put an S down here. That might have been a little confusing. I think, Adam, you were the one who was like, who's X? Okay, it's position. I should have kept it with the same variable. Could have been S, 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 or X, 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 but either way, my position function will always be, who's this 32? He's gravity. He's a fact that I can bank on as long as I'm measuring in feet. So therefore, I can bank on the fact that my position function is going to, for any constant acceleration model where acceleration does not change the entire time, which for free fall, there is no little engine with an accelerator pedal, or deceleration, there is nothing going on once the ball leaves the person's hand. It's just gravity and gravity alone that's acting at that point. If I have constant acceleration, I can always say this. And so if I plug in this negative 32 of its feet per second, it'd be negative 16 t squared plus v sub naught t plus s sub naught. Ooh, I need to change him too. But anyway, long story short, you guys just figured out how to find the equation that was given in the paragraph to all the problems in section 2.2 that you had to read, or else you would have been lost. They were giving you this equation, just you had no clue where it was coming from. It was coming from gravity and free fall. So, free fall. Is that the name of a roller coaster? Kind of sounds like it. For this problem, guys, with the ball being thrown up and then coming down, we were supposed to find two things. We were supposed to find the position function, and we were supposed to find when. I know it's a when because that's who? Time. So I know that the question was a when without even seeing it because that's time when the ball hits the ground. And I know that because position is 0. And if position is 0, where's the ball? On the ground or on whatever place I have marked to be my 0 with my height of 0. So using all of that blah 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 off to the side, what can I do if I know this information for this problem? Plug it in. So I'd be super snazzy. I could say, ooh, I'm trying to remember where all this comes from. So I know gravity is acting, this is a feet per second. Then you could get negative 32t plus my v sub naught is 64. So I could actually fill in my velocity, and I could go backwards again to fill in my position by taking another integral. And so I'd end up with negative 16t squared plus 64t plus 80. Dimensional analysis, I need to make sure that everything matches up. If one was miles and one was feet, I'd be in some trouble unless I made them match. But feet per second, feet, I'm good. My position function is done. It's a simple integration from gravity and then an integration once you plug in your initial velocity. But letter B, now what? Take my quadratic and set equal to 0. Now, it kind of stinks whenever I set a quadratic equal to 0, because then you would think either I get to use my calculator, but maybe my window will be weird, because that's an 80. My normal window's a 10 by 10. Or maybe I can factor. Nope, that'd be a minus. Is this one that's not too bad to factor, guys? I think it's a minus 5 and a plus 1. You guys agree?
Yeah.
So maybe it wasn't too bad after all. Maybe going to our calculator would have made things way harder than it needed to be. But wait a minute. This shows there are 2 times it hits the ground. 2 times it hits the ground. What's the only one that I'm supposed to answer with and the only accurate one for this problem, Adam?
Positive.
Yeah, why the positive time? Well,
okay, you could, but like.
Why? How? How could you?
It's just like him walking up to like throw the ball.
It's just what was happening before he threw it, right? Negative time was just what was happening before.
Like,
but was the ball coming from the ground to his hand to be thrown? No. So there. At -1, it wasn't following this model. At -1, it wasn't thrown. Gravity wasn't acting on it, at least not in the same way. The guy was holding the ball like it was right here. It's kind of like his position function is like in his hand, actually in his pocket, then in his hand, then being thrown up. Here we go. There's a parabola. So it's a piecewise function. Practically a lot of life are piecewise functions. Interesting. But long story short, even though the math says yes -1 and yes 5, I say that doesn't make sense because all of this started when t was 0, right? It wasn't thrown before that. So when? 5 seconds later. Because how do we know it's seconds?
Feet per second.
Feet per second. 5 seconds later from, if they want like an actual time, I don't know, I need to know what time he threw the ball, and it'd be 5 seconds after that. So I can just say, 5 seconds later. Not t equals 5, but put it in context. When? 5 seconds later. Yeah, Kathleen, what's up?
On the AP, like for answers like this for the FRQ, when you have to like write out the answer in context, like you said, are you allowed to like abbreviate things?
Like SEC instead of seconds? As long as they're common abbreviations, yes. I wouldn't just use S like we do in feet per second, like that's a common feet per second one. But I would write out like SEC, but that's okay as long as it's normal. Now when we do pips, that's a little bit dangerous because that's not necessarily like a broadly everyone internationally does a pip. But crit, well it's short for critical numbers, that's okay. Or NVT, IVT, EVT, all okay. Yeah. So guys, we've made it through one word problem. I would love to do a couple more, but I think most of us need at least some sort of like getting us alive because right now we are so dead. So to that end, since we didn't get to do integration competition yesterday, let's do integration competition today. Here we go. So integration competition. You guys have one whiteboard per group. We're going to go back and forth taking turns. We have 1, 2, 3, 1, 2, 3, 1, 2. We can just stay in our groups. My groups of 2, do you mind that you have one fewer person than some of the others? Okay. I am going to unveil a problem. Decide who is going to have the marker first. Whoever has the marker first, the next person has the next problem, the next person and now comes back to the first or goes to the third, and then keeps going from there. I'm getting a whiteboard so I can put the solutions on it. We're going to do the same rules as we did last time, in the sense of, if you are the first one to get it right, your group gets 2 points. If you get it right, you get 1 point. And if you get it wrong, at any point, you get 0 points.
Can you use our notes?
Yeah, let's go ahead, because last night's homework you guys weren't necessarily doing, integrals last night, so it's not necessarily fresh in your mind. I don't mind that. I don't know. Ooh, someone's Hamlet though. See here. To be or not to be?
That is the question.
That is the question.
Tis nobler.
Whether 'tis nobler in the mind to suffer the slings and arrows of outrageous fortunes of fire.
We're doing that.
To die to sleep, to sleep, to chance to dream.
Okay.
It's questioning suicide. It's kind of practical for this day and age. All right, ready? On your marks, get set. Go.
Ooh. I'll burn them.
Remember, you can collaborate, but the person with the marker is the only one to be writing it down.
So it's an S plus 1.
Did you not
It does not have to be gorgeous, it just has to be right. Oh, no! Yes! You forgot one little thing. You forgot to see that everything was there.
Oh wait, they got it first, so.
Yes. 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 Now.
Wait, what do you think?
Oh, you forgot to see that it was all there. You guys
Oh, C
touch it?
plus C.
You didn't touch
Yo,
it.
mama.
It's okay. It's okay. On any forever quiz at this point, on these forevers, I would remind you to see that everything was there. But some of you just realized, oh, yeah, I might make that mistake. So it's not just on the person who wrote it down, it's also on the entire group. It's also on the entire group. So we have, let's see, groups 1, 2, and 3. All got 1 point. Group 4 got 2 points. Group 5 and 6. Oh, sorry guys. It's okay. Come back. Come back. Number next one. Someone new at the marker? Board is erased. Good? Write down the problem first and then go. Don't forget to see it's all there. Yes.
Yay.
Oh. Yes. Yes. Yes.
That was good.
It was like, can you read me your answer?
Yes. Hold on. Let me rewrite it.
We're good. Okay. Just making sure it was what it was. Yeah. On the AP, you would have had to have had parentheses, otherwise it's 4 minus. Does that make sense?
Yeah.
It's just the derivative.
Yes.
of that. Do we have to write the problem down, or can we just like?
Nope, write the problem. Write the problem. Group number 1 was the first one this time. Everybody else got 1.
Yay. You know, I'm gonna turn my desk over.
Okay, next one.
Number next one. I like that.
It was negative 4 cosine of x plus c.
You prime.
You prime. Ready, set?
Oh.
Woo! Let me read it to you. 7x squared times the cube root of x dx. 7x squared times the cube root of x dx.
Now, you write it. So, you write it that x is 1/3.
Oh wait, because you can
Double integration power. So you get it. Oh yeah.
This is
Basically, no. 5/3 x raised to 5/3.
so it's n plus 1, n plus 1.
No, this is that's 7. So 7 x to 5/3.
This is plus.
Not plus.
Now,
Here, try again because you misread it.
n plus 1
Times, not plus. I'm just showing the answers to the earlier two, not showing any work on this one. Get my attention if you have a solution.
So it's going to be 5/3 plus 5 is 7. No, you're gonna have a 7 back.
Over 3.
X
Super close. Your power was wrong.
Oh, all
Yeah.
over 5/3. Just show your work. 5/3.
So check these two together.
Well, no, not like that.
Your work was perfect after that.
Yeah, all over 5/3.
Your power.
So you have 8/3.
So your work is perfect after that.
And then 7
Yes.
x to the 8/3.
Yes. I'll give you both tied for getting the first.
Now you have to simplify. Because multiply this 3 over 8. 7 times 4.
Because this is 1/3. You should combine them.
I'll give you half. Yes.
Well, you don't need that line anymore. You're just gonna have x to the 8/3 power.
My ones that got this one wrong, if you get it right, I'll still give you a point. Just because this one was more advanced than any of the
You
others.
see?
What's your power?
8/3.
Try again. The power to begin with is wrong. I think your derivative rule is right. But the power to begin with is wrong. So I have 3 groups that are still trying to figure out that correct exponent.
So 2 would be 6 over 3.
Exponent
It would be
rules.
7/3.
With like bases you add.
Because you
With
can't
like
do
bases
the
you
function
add.
you do on 6 over 3. That's so. First left. Yeah.
With like bases you add.
So now that's going to be 7x to the 7/3. And then now you power. So 7/3 plus 8/3. All over 7/3. Yeah. 7/3 plus 8/3. Yeah.
It's sounding good.
So now, 3 over 7 times 7 is just 3, right? It's 3.
My ones that got it wrong the first
3
time.
x.
Think about what mistake you made. My ones that got it wrong the first time. Think about what mistake you made. And will you make it again?
Oh wait. So we forgot to add 7 to 3. Oh wait. That's why I'm changing here. So it's going to be 10
One last one, try again.
So
What mistake did you make the first
this is why
time?
you
Will
have to
you
make
make it
sure you
again?
put 3/3.
Adam, what problem were you doing up here?
10/3. So 10/3.
It was just from-
3 times.
There were like
was
practice
gonna be
SAT
21
stuff,
right?
and it was
So
one
21
like
I was
that.
like, you shouldn't be seeing X's and Y's
No.
in this.
For the,
I was worried I gave you something way harder than I should
No,
have.
it was just crazy. Kathleen.
I think so. Misty?
Did you
Is
know
that a 10 in it?
There's no
Yes.
official
Okay.
like
In the
name
exponent.
for SAT. It used to mean something, and then like the
Did you know they're
government said like
changing
it
the
doesn't apply
ACT
anymore or something like that.
that for September 2020, if you want to take the ACT and you do bad on a section, you can just redo that section.
Really?
You guys have it easy.
Are you serious? Take the ACT.
Yeah. Isn't that
Sorry.
insane?
Isn't that what the sections are for subject tests for SAT?
I think I got like 20 something.
I'm gonna give a bonus point to anyone who can rewrite this in radical form.
Ooh.
Whoever gets it first, who can rewrite that answer? Let's say all the multiple choice had a radical in it. Any group, any person?
Like a
With a radical, with a root. Ooh, Kathleen.
So.
Okay.
No, she wrote it in a root, but how can you write it in a simplified root?
Ooh, simplified root?
Uh-huh. Simplifying the radical. I'll show you what they gave. They weren't wrong, but it can be written simpler. They gave me 21 over 10, the cubed root of x to the 10th. That's good, but x to the 10th, there are some cubes in there, aren't there?
Yeah, there's 2 cubes.
How could you write it simplified? Because it was written simplified up here. How would it be written simplified? No.
Misty?
More than that.
Okay, more than that.
Your x just disappeared.
No, the X is there.
Where? But it's underneath. Where'd all 10 go?
Because there's the 1.
If it
You
was-
can go to 9 X's.
If it was x cubed rooted, it'd be.
I don't know.
No. If it was x to the 4th, no. All you have right there is x to the 1/3. I need x to the 10/3. What you have is x to the, actually you have x to the 1/2 because your third is gone.
Well, yeah, because
we
you
get
get rid of.
penalties?
10/3 does not equal 1.
Are there penalties?
I think we're wrong too.
Hello?
No, no penalties. 10/3 does not equal 1/2.
Okay, no
Okay.
penalties.
No penalties.
No penalties.
Wrong.
Too late.
Is this, wait,
You have x to the 21/3 written down right there.
is this x to the 21?
You took out that
That's x to the
Oh,
10th.
maybe.
I've got it.
Right.
Was it
Show your group and make sure they understand.
Adam, what'd you get?
What's the simplified way of doing this one? I just need you to simplify the improper fraction as a mixed number. What's 10/3 as a mixed number? 3 and 1/3.
Whoa.
3 and 1/3.
Is that for anything?
Oh,
That's how simplifying radicals will always work.
that's what I thought.
So this was 2 1/3. This is 3 1/3. That's how it would have been written in simplified radical form. Ooh, it's a little intense. It's a little intense. Okay, I'm going to zoom in and I'm going to go down and let's go find, I think, that last integration competition problem. You ready? Boop, boop, boop.
I don't think that's
New person, marker, ready? Oh, we have 2 more. We have 2 more. Oh.
Miss D, why did you
Oh.
get the easy one? Second.
I gave you a hard one.
What? I get the hardest one.
I know.
Oh, let's see.
Oh, Missy! I'm really wait, she looked at me first. That's bad. Yeah.
Austin, is he right? Did you guys talk it out at all?
Miss D, it's a competition.
It is.
Talk it out.
We talked it out.
Talk it out.
Okay. I wrote DX.
Now you wrote it down.
Miss D.
Good.
Mistakes are too hard.
Good. Good. Happy.
We didn't compromise teamwork.
Yeah, Adam. Now why don't you give up your paper now?
Has anybody not? Oh, there's one more.
That's what you do, Adam.
I'll bite you.
We died. Oh,
Give
you
one more.
guys got the last one, yeah.
Give one more.
I was putting it like this.
Yeah, and it's not a negative, right?
No.
Okay.
I put
Group 5, 6, or 2. Can you
Yes, I
guys just
did,
get
but
this
I'm
one?
putting it in my head.
It was x to the 1/2 dx, which plus 2 over 2 is x to the 3/2. You guys are doing great with multiplying by the reciprocal. Like, we haven't made any issues with that. It's more the exponents that have gotten us off. But otherwise, you guys are doing a good job. One more. Now we're on the last one. Ready? Set. Whoop.
Oh,
Go.
baby girl.
Yes.
Ready, set, go.
Have you read this in any way?
I love that you're using the word rewrite.
Yeah.
Minus x squared.
Don't the x squared just cancel out?
John.
Or whatever.
Just get a right answer.
Just kill that.
So much. No.
That's good. That became that. This is off. And x squared was off.
Well, because we're going backwards.
2 plus, I don't know, I kind of like, it's 2 over 2. It's not over 2.
I have a correct answer. I'm still giving initial points, but I'm also looking for, and this is up for grabs for anybody, I'm also looking for that correct answer written in a fraction form, like the beginning problem.
Oh.
Kyle, give me your answer.
Negative 3 over x minus 1 plus c.
The 1 is off. Yes. Yes. Okay, I'm going to write an accurate version because everyone's checked in unanswered, but I want to see if anyone can get, it ended up being negative 3 to, sorry, x to the negative 1 minus x plus c, because this ended up being rewritten as 3 over x squared minus x squared over x squared. The division has to distribute.
Thank you.
But I'm curious. See how it was all together in one nice big fraction to begin with?
Yeah.
The multiple choice answers might look like that too. How can you make this look like that? There's one more point out there. It's not the same thing as, it's different, but how can you get this as a big old fraction?
Oh, a big fraction?
Yeah. Get it together. But yes, that's the first step.
That's right, because you have the constant. Okay.
Close.
Not this one, because it's already like, she wants in one
Yes.
fraction, this is already.
I got the constant.
Vico, you forgot to do common denominator on the x.
That 1 comes a constant.
Oh, common denominators. You guys thinking common denominators?
It's already common, so then you can just add it to.
You have to multiply it.
The plus c can be separate. That's okay. The plus c can be separate. That's okay. Sorry.
Take it an x.
I had to keep going, but you're right, Madison. That's not wrong. Get a common denominator to get it into one fraction. Oh yeah. There you go. I didn't see that one. Yeah. Yeah.
I think I
Good. So, group 4, I'll go ahead and give you 2 on that one because it was a bit advanced than the rest of you guys. And then you guys got it, and then you guys got it, and then you guys, yeah, you guys. And then backwards. Got it?
Oh, no.
Negative 3 minus x squared all over x? Got it. Alright, cool kids, excellent job. Whether or not you're at the very top or in the middle or at the bottom, it doesn't matter. Did you get some points, aka you know how to anti-derive?
Yes.
Are you masters at it?
No. I'm
But
close.
are you improving?
Perhaps.
Yes, that is the point. That is the point. We're going back to our notes and we're going to go ahead and do just one more motion word problem as practice for tonight's homework, maybe 2 if we can fit it in. But our final winners were group number 4, Kathleen and Wyatt. And that was your last time working together in your current groups.
Oh. She just dropped all
Tomorrow. We gotta change it up. We gotta keep it fresh. So mean. All right, pass up your markers, toss up your little baby whiteboards, your tissues you can throw away on the way out the door.
More ignorant.
I wish I could say him. I
allowed you
said
one
I wish I
last
could
time.
say
He's
when
gonna be a
talking.
bully, so don't say it.
What?
Wait, how do you tie?
I don't know. I don't argue with the point
like,
Callie,
keep
Miss
going.
D.
But they have 9 and you have 8. I'm confused.
Wait, is that one a written?
Yes, there's 4.
Oh, why is it so light, Miss D?
My markers are kind of dying. All right, motion problems. You guys ready?
Nope.
I'm gonna come back and grab it from you, Kathleen. But for right now, ooh, did you guys just see an integration quiz that I just passed over?
What?
Ooh. Tomorrow, beginning of class, you're gonna have a blank piece of paper and you're gonna do some integrals on your own. And let's see if I can get you some free points. Maybe not free points, but maybe easy points.
Excuse because I was.
However, if it's a
Hands
quiz,
up.
do you think you're using your
Hands
rules?
up.
No.
Yes.
No. Wait.
No using your notes or forever cards tomorrow on the integration
So
quiz.
study
It is
forever
not a
cards
forever
tonight.
quiz. It is not a have every rule memorized. It's a me giving you 2 or 3 and seeing how close you can get to the right answer. Not the perfect simplified right answer, just a right answer. Yeah? Tomorrow, be ready? Study those rules tonight a little bit? Sound good?
Yeah.
Yep.
This one is the one over.
Or at
on
least
the-
do you understand
upload videos, right?
What?
You upload these videos?
Ah, it had a screen shade on it. All you could see was integration quiz, screen shade.
Shane.
Use. Oh, hey, they tell us what acceleration is. Oh, but okay, it's gravity. Whatever. Negative 32
Gravity.
feet per second squared. This is interesting. With what initial velocity must an object be thrown upward from ground level? All of these words are important. To reach the top of the Washington Monument, which has a height of approximately 555 feet. With what initial velocity must an object be thrown upward from ground level to reach the top of the Washington Monument, which has a height of approximately 555 feet? I'm not going to necessarily let you guys agonize on this for a long time, just because I might want us to actually peek at the example on the other page, which is a little more practical for the majority of homework problems. But this one kind of shows you how interesting it can get. The next problem is a bit more typical, so that'd be a little bit better for practicing the concept. But this one's just to throw your mind for a little bit of a loop. I'm going to show you what I'm able to pull out of that paragraph. Because we have to pull out something or else we're in some trouble. The nice thing is this starts with the question, so I know right away what I'm supposed to find. I'm supposed to find my initial velocity such that, okay, well here are my givens. I'm supposed to find my initial velocity, but what am I given? Well, I'm given an initial position. I'm given an initial position, whether or not you realize it. What's my initial position?
0.
Because I'm starting from
Ground level.
ground level, so I realized that. I picked out this right here, with what, that's my question, that's my unknown. And then I need this, what else do I need this to have? I need this to reach,
555.
now to reach, what do I set equal to 555? Do I need it to go past 555? No. I just need it to make it to 555, right? I don't need it to go past, I just need it to make it to 555. Question, what kind of graph would an object being thrown have? If time was the x and if height was the y, what kind of graph would it be? Would it be a line? Would it be a cubic? Would it be a quadratic? What kind of graph? Yeah, it'd be a quadratic. Now technically it's just being thrown straight up and straight down, but when you add time to that, it's going to look like a parabola. Now, I just need the highest it goes to be 555. What's so special about the highest point of a parabola? Not inflection point. Careful, that would be of a cubic in the middle. But of a parabola, it's a vertex or a critical number. It's a vertex, and the vertex will always be at a critical number. Now, what kind of critical number? Because critical numbers can be 0 or d any. A 0, because what's the slope at a vertex? 0. It's not undefined, and it's not a sharp point. So I know right away that my S of C, or my critical point, is going to be 555. But what do I also know about my velocity there? What did we just say is our derivative? Or our rate? 0. So it's kind of crazy, but I'm making the vertex of the critical number, V is already being used for velocity. I'm making the vertex of my position being, or hitting, 555. And I know that at that vertex, my velocity is 0 because it's a leveling off, technically a momentary sliver stoppage. Velocity is 0. It's at rest for a split second before it starts falling. Okie doke. So this is a free fall model, which means I'm allowed to use that nifty, hey, start with gravity, right? From gravity, I can move to velocity. Could you memorize it? Sure. For the AP, do you need to? Not really, because they're not going to give you ones that are quite this simple. But you are going to need to know that velocity comes from the integral of acceleration, hence why another Forever card is coming. Plus initial velocity. Uh-oh, I don't know who that is, do I? Oh, that's the point. I don't know what that is. And then position, I'm taking an integral again, which would be negative 32 over 2t squared plus the guy I don't know, plus initial position, which is 0. This is all using those relationships of formulas that we saw on the page before. Oh wait, 32 over 2, isn't that 16? Okay. Now you guys realize we have a lot of unknown stuff up here, right? We don't know him. And we don't know him. Oh, but wait, what can we plug in? Good. We already did S sub 0 is 0. We already did that. But we can plug in a position and say, oh, hey, when t equals c, I have 555. When t equals c, and what else do I know besides position at that vertex? Not just how high, but also how fast, which is 0, which is the other equation. Okay, that's what do you do when you have 2 equations and 2 unknowns in math? Substitution, elimination. Don't do elimination, that's gross. Substitution. Who don't we really care about? We care about him. So who's the other guy?
C.
Okay, so let's just get C alone and get rid of him. So C is going to equal what? Negative V sub naught divided by negative 32, which is V sub naught over 32. Is this a good old-fashioned math thing I should be able to figure out on my own? All I need to do is plug in terms of V sub naught and then solve. Dun, 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 dun. Okay, the math will take a little bit of time. But we at least see the math, right? I get my C alone. I plug in chug, and then all of a sudden I have something just in terms of my little V's. You can just call them V if you don't like the V with a subscript 0. All you gotta do is solve for V. But this is a really hard one where it was like a paragraph or it was a situation. I'm like, okay, I can visualize this. That's great. And I'll like throw in a ball up. Hopefully it fits. But it's hard because a lot of stuff was missing. And so as you guys walk out the door today, you can just be peeking at something like this where the information is a bit more normal. They actually give you like V sub naught, they give you gravity, they give you some times to plug in. Homework is going to be mostly like this where they give you numeric clues that you can plug into free fall models. So have your notes close, have your examples close, come tomorrow with questions. Sound good? Okay. And just peek a little bit on your integration rules that way. Not that you have to like say them all word for word, but you can use them to solve some integrals real quick beginning of class tomorrow for an integration quiz. Bye guys. Let me try to pause the video. Happy Wednesday. Happy the week.